Welcome to the Mr. Smart Maths channel, and my name is Mr. Smart. In this video we're going to be looking at finding the distance between 2 points with the help of Pythagoras' theorem. Okay, so let's look at the 3 line segments that I've drawn here. And in the top left one, we have a distance going from left to right. So we can just count the number of squares. 1, 2, 3, 4, 5, 6 squares. And so that's the distance between those 2 points. Okay. In the second one, on the left-hand side, we're just going to look at the same thing but going up and down. So I'm going to start from the top and count 1, 2, 3, 4, 5. And so that means the distance between those 2 points is 5 squares. Now the difficulty with the third line segment is not only are we going from left to right, but we're also going up and down. And so we've got both there. And to count the number of squares, it's difficult when you're trying to count diagonally across a square. So we actually need something else to help us, and we use Pythagoras' theorem. And so what we do is we turn the line segment into a right angled triangle, which you can see there on the top right. So Pythagoras' theorem, we need to set up our A, B and C. A, B and C. And remember, Pythagoras' theorem states that a squared plus b squared equals c squared. Okay, so we can count the number of squares for the lengths a and b, and this will help us then to figure out what c is. Okay, so c squared then equals, so a is 3, so 3 squared, b is 6, so 6 squared, and we can work out what 6 squared and 3 squared is. So c squared then equals 36 plus 9, okay? And 36 plus 9 equals 45. So if c squared equals 45, then we can determine that c is going to be the square root of that. So at this point, we just need a calculator to work out what the square root of 45 is. And the square root of 45 comes to, as you can see, 6.70820 and so on. Let's go to one decimal place and call that 6.7. Okay. Now it doesn't matter what direction you're going, whether you're going up or down, when we determine the distance. So here's another line segment. And this time you could argue we're going in a downward direction and in a right direction. Now I know in terms of coordinates and vectors that might mean pluses and minuses, but here we're only looking at absolute values. Okay, so we don't need to worry about that here. So let's just label my hypotenuse and the 2 shorter sides. So there is my C, there is my A, and there is my B. And remember again, Pythagoras is A squared plus B squared equals c squared. Okay, so let's count the squares then for a and b and figure out what the length of the side c is. So c squared then equals, well, b squared is 5 squared, a squared is 2 squared, and 5 squared is 25, and 2 squared is 4, and 25 plus 4 is 29. Okay, so to find c, we just need to find the square root of 29. And if I go back to my calculator, let's find the square root of 29, which equals 5.38516. Again, I'm going to go to one decimal place here and round that up to 5.4. Be sure to check out the Mr. Smart Maths channel on YouTube, and don't forget the website mrsmartmaths.com. See you again soon.